Today I am heading to Chongqing University and Chongqing University, two universities in the city of Chongqing, a huge city. I'm taking the bullet train and I'm going to take you with me. Stay tuned to both universities. See you later.
So I'm with Professor Bauji in his office.
How do you say?
Very nice.
Many buildings have their own green roof.
Yeah.
But not like the very plan, not like the public green roof. This is the community garden.
Ah.
Welcome to this session. So today's presentation title is the development of digital twins in urban parks to mitigate heat waves vulnerability. My name is Attia. I come from Belgium, Beliche, and I work in sustainable architecture and sustainable cities. I acknowledge Chongqing University for this generous invitation, and I need to acknowledge the partner of this collaboration, the Belgian Research Fund FNRS, and the Royal Meteorological Institute in Belgium and the city of Brussels. Also, I need to recognize my collaborator, Hisham Arar and Elhabodi Matalla, who are working with me on this project since 3 years ago. In the coming years, we will need to prepare our cities towards or against shocks. We will have extreme shocks, extremes of floodings, heat waves, and so on. And it's very important to live with these conditions. Whether it is fires, heat waves, floods, or droughts, these are phenomena we cannot avoid, and these disruptions are going to become the normal in the coming years under climate change regime, unless we are able to reverse this phenomena of climate change and reduce the global greenhouse gas emissions that are released in the atmosphere. Now, when we look at the term resilience is not meaning resistance. Resistance is something, resilience is something else. Resilience means that we are able, after falling, standing up again. And it's very important to calculate the time you need after falling down. If you have a burnout, it's not about the burnout, it's about how long you will stay in the burnout until you can recover again and become functional. And sometimes it takes a year or more. So the same happens like with humans and nature. It happens with cities. So today, we need to prepare our infrastructure, our cities, to be mentally ready that if there is a shock or a disruption happening, we will have a failure because it's impossible to size and design everything for the extreme conditions. We always design for average conditions, and then when the extreme condition happens, we have to adapt temporary, and then we can recover back from the failure, and then we go back to the normal conditions or to the minimum performance conditions. So this means that we as city planners and building designers, we need to have access to weather data and weather files, where we have extreme weather files for extreme conditions, extreme rainfall, extreme heat, extreme temperature scenarios, extreme pollution scenarios, and these extreme files can be propagated using projection and futuristic weather files. And I ask every researcher today working on any infrastructure or city or urban planning or neighborhood to think always about mid of the century, end of the century. We are in 2024, yes, but you are going to build a city that will live 1,000 years or a building that will live 300 years. So in this context, we need to have future projections. And we need also to have short, extensive, or short events with extensive conditions. So we put a scenario of power outage, heat wave, in the same time. And then we start to say, okay, how much is the power outage? 32 hours, 24 hours, 18 hours. And depending on every scenario, we start to do short-term event within the long-term vision of the climate extremity. And this is not only during summer. We must also take into account winter. Because at least in Northern European countries, we have a lot of cold spells. Cold spells will be very cold days with freezing temperature -20. So the infrastructure will be paralyzed. There will be most probably a big power outage. People will go try to get any sources for food. They cannot leave their homes. So in these scenarios, we need also to have a prepared scenario for these conditions. Now, we are monitoring in Belgium since 2017 two correlations, two variants. Variant number 1 is the outdoor average temperature, and the variant number 2 is mortality. And definitely, we can see that during COVID, there was a big problem, especially in the first year in 2019. But after COVID, we have other peaks related to heat waves. COVID now is finished in Belgium, but heat waves are not going to finish. And normally we have an average death rate per day in Belgium, 300 persons. 300 people die every day in Belgium, no normal death. But when we have a heat wave, with every 1 degree extra, we have between 10 to 20% additional mortality. So it's very important to prepare the cities and take this indicator of the deaths per day as a relevant indicator. We did also some projections on future heat wave scenarios. On the x-axis, you will find the duration of heat waves. These are 10 days heat waves, 20 days heat waves, 30 days, 40 days heat waves. And on the y-axis, you can find the temperature starting from 30 Celsius, 32, 34. And these are the projections for the city of Brussels. And I think it will be very useful that you try to draw the same graph or the same diagram for your own city that you are working on. So that you start to say, okay, until 2100, what will be the average duration of a heat wave and what will be the average temperature? And this means that you need to collaborate with geographical people or climatologists and work on a lot of weather files and do a lot of projections. And based on that, you can really have very valuable information. And as you can see, what we learn in Belgium, that we should not be surprised that we might have a heat wave 40 days. 40 days non-stop with a temperature of 34. This is for Belgium unbearable. It means that we will have a very high mortality. All buildings will be very hot. We don't have air conditioning technology. And we cannot in 1 minute ask to equip buildings with cooling technology. Now, therefore, the only solution is to use the acupuncture approach, meaning that we cannot have a central generalized solution for everything. We need to select and pick up. And as you can see, this is an example of, this is the grass that should be green. It's completely burned because the heat wave, it's dry, it's hot, and there is no other option. In this sense, we started 4 or 5 years ago a project on characterizing the heat waves in the city of Brussels, and we had some satellite mapping. We started first with satellite mapping. Unfortunately, very few studies in Belgium does observational research or measurement in reality. So we started with satellite mapping. From that satellite mapping, we did some hotspots identification. We started to identify the urban heat island effect hotspot in specific areas. And based on these specific areas, we started to decide which kind of square we would acupuncture our investigation. And then we started our monitoring campaign. We rented this crane car. We bought 15 weather stations. We made an agreement with the electricity company, and we start to install our weather station with our laser meters and radiation meters on these installations, and putting always also in the countryside a reference weather station so that we can compare. And then the second stage was launching thermal imaging with drones so that we can get an impression of the emissivity of the surfaces and to characterize the morphology of these squares. And finally, we introduced the surveying, asking people directly, and we, based on this information, we started to make our collage to propose solutions or improvements and start our 3D modeling in MVMIT. So these are the steps or the cycle of information we did, and we are kind of surprised that we could not find any information before from researchers who did this before in Belgium. So we try now to focus more on experimental and observational measurements to make sure that we can start the modeling process, because the problem with modeling process, most of the time, people only do hot spotting and modeling, but they don't do the cycle of real measurement. And it's very important to bring the component of real measurement to the picture to make sure that you can come up with evidence-based design recommendation and advices that will work. Because one of the key factors of the urban heat island effect is the airflow. The airflow, the velocity, the air speed, the air temperature, and how the morphology of this park or of the urban neighborhood will influence the air penetration in the spaces. And for sure, surface temperature is important, finishing of materials is important, the greenery, the vegetation, the shading coefficient, and so on. But still remains, in my opinion, one of the key factors is the air velocity. And this can only be done through 3D modeling coupled to real measurement for validation. So this is already work that was done for the city of Brussels, and we have it already out. We're still working some publications to get it out, but the whole experimental work is done. Now comes the problem of today's presentation, the digital twin. I'm going to talk today about the digital twin. Well, we started to do an investigation in many cities in Belgium. After every summer, suddenly, when there is a wind or storm coming on the city, we find trees falling on people and people die. September or October. If you just see a statistical accident by tree fall or tree falling on people, always September, October. Why? We figure out actually that during the summer season, in the last years, it rains very little. The soil gets very hard. The roots of the trees die. Until the summer gets over and we start getting into September, October, in Belgium or in Western Europe, the wind is very strong. So the wind hits this very big tree, which could be half ton. A tree could be 500 kilograms or even 1,000 kilograms. The roots are destabilized because the soil is very hard, and suddenly you will have the wind, and then the trees fall on the people, and then you have accidents. So we started to understand what's happening, and we found out some cities, they ask their water or the fire department services to water the trees during the drought or during these hot summers to make sure that the soil will start wet, and then when the winds of September, October come, the soil will be stable. But in Belgium, we don't have any policy like this. This is pictured in Germany. So Germany, that during summer, the firefighting services are responsible for watering all trees. We don't have that in Belgium. And because in Belgium we always think that it will rain, because we are a rainy country, we never think to introduce artificial or man-made irrigation. So here comes the importance of the concept of digital twin for urban park. It means that if we will continue with these excessive temperatures and the excessive drought in the coming years in the climate of Northwest Europe or Central Europe also, we will need to have more information about our urban parks. And this means that from one side, we are seeing the park as a place for leisure, entertainment, well-being, people can go play sports, activity, dance. But on the other side, we must see it from a pure physical and hydrological point of view. Physical and hydrological means that we need to know what is the regime temperature overall. We need to benefit from any presence of nearby weather stations, and we need to have also soil moisture sensors to understand how far is the soil dry or not dry, and what is the nature of the soil, and how long can the tree roots survive the drought, and is it going to die or not, because some trees, they have deep roots, some plants or trees, they have horizontal roots. So the deeper, it's difficult to turn them, but if you have a horizontal rooting system, it will be very difficult, and when there is a drought and wind storm, the tree will fall. So it's very important to look at that, and here comes the importance of having weather sensors, soil moisture sensors, and to have an irrigation system, artificial irrigation system, at least in the crucial, most important parts. So with the city of Brussels, we started to select one of the city parks, which is the most heavily vulnerable. We created a list of criteria of vulnerability, and we said, okay, these are the parks that we think they are very vulnerable, and if there is a long drought, there is a big chance that the trees can fall. And we started to study the following parameters for an advanced irrigation controller system. We studied the size of the landscape, the available weather data, the SMS sensor connection system. So we created a system that you can have an SMS connection to send a signal from the park, because you have only two options if you want to send a signal from the park. Either you do it through Wi-Fi, and then you need to have a device that you put in a SIM chip, and from the SIM you send the message. Or you must have a Wi-Fi network to send the message, because we are trying to equip the trees with sensors. So how the tree sensor will communicate with your server. So it's very important to have an SMS sensor connection. Look at the performance that you are expecting from your irrigation. What do you want from your irrigation? Are you going to do full irrigation, drop irrigation, partial irrigation, then a controller interface, a cloud connection, looking at the cost, look at any additional measurements that we might need, because we need to have a sensor for the soil, sensor for the air temperature, and sensor for the airflow for the water drip irrigation system. And finally, we need to have a building automation system or a building management system, BMS or BAS, and for sure we need installation and program. So with the city of Brussels, we started to study these parameters, and we started to focus on examples in Australia for an already existing exercise. So this is a project in Sydney, Australia. They followed the same. We followed the same approach. So we tried to copy what they did in Sydney. We started doing a heat wave vulnerability mapping. Then we started to define the places that are considered as cool parks. And here it was the Sydney Olympic Park. Then in the project of Sydney, they started to introduce 50 low-cost sensors. And they had a weather station, 30 weather station, also low cost. So the sensors and the weather station together communicate to a digital twin that is connected to the server or to the cloud. And for sure, there is an artificial intelligence module that will regulate the irrigation system and start to give a command or an algorithm depending on the condition of the climate in the previous days, based on that amount of water that will be needed to make sure that the soil is always wet. And for sure this requires some workstations for processing all this information in order to come up with an optimal control algorithm. And finally you will have an irrigation system that is self-automated based on predictive control feature that is measuring the last 7 days conditions, and based on that it will give a command to the irrigation system for this urban park, especially for plants and species that are at risk or a high vulnerability based on the assessment that was done during the heat wave vulnerability mapping. So we are in the steps in Brussels to do the same process.
Yeah, the campus was built around the 1920s.
1920s.
Yeah, so almost 100 years, but 90 years old.
And do you know how much is the number of students in this university?
Around 45,000.
45,000.
Yeah,
Okay.
and also we have several campuses. This one is in the Shopping Bar district. It's the old campus, yeah, and also the main campus. So, and supported by the Chongqing government, if we would like to develop the smart city or smart things.
Yes.
And new materials, we have built another new campus in Huxi district, and that campus much newer and large, and also the facility are modern. Yeah, and open, and the terrain in that district is flat.
Yeah.
Not like this one, mountainous.
Yeah.
Yeah. And that one is mainly for the first or second year student, undergraduate student.
Okay.
Yeah, this one mainly for the master and the PhD or maybe the senior.
Mm-hmm.
And also for the ministry building.
Yeah.
Yeah, it's also in this campus. And also this is the campus B. We have another campus A.
Yeah,
The road,
I
the
went
road.
to.
Yeah.
They take me tour in campus B yesterday.
This is the B.
Sorry, then
that's
A. Yeah.
So, and this campus is mainly for the architecture, faculty of architecture.
Ah.
Yeah, we have 5 schools: architecture and urban planning,
Yes.
and civil engineering,
Yes.
and for the real estate. Yeah, the building we deliver the clocks, and also ecology and environment.
Ah, this is student housing.
Yeah, this is the student dormitory. This is the school building, the School of Architecture and Urban Planning, Chongqing University.
It's interview time.
So, hello everyone, I'm Bao Jiehe. So, I'm currently a professor at the School of Architecture and Urban Planning at Chongqing University. So, Chongqing is in the middle field of the Yangtze River. So, it's my pleasure to have Professor Shadi to visit my school. Yeah. So, my field of research actually is the combination of the architecture, urban planning, and urban design, landscape architecture. So currently, my research topic is on the urban heat mitigation and adaptation in order to develop the heat-resilient urban planning and design paradigm. Yeah. So actually, we are working on the urban climate and the sustainable built environment, and especially on the urban climate for the urban heat. Urban heat is the challenge, the combined result of the heat island effect and the heat waves, especially in summer seasons. So the research topics under the urban heat challenge covered several topics like urban morphology and especially for the urban morphology characteristic optimization for the ventilation performance enhancement and for the solar the shading and to create more shades in the urban areas. And also we have some work on the decision support tools trying to close the gap between the research and the practice and to enable more urban planners, designers, and managers to use our techniques properly and scientifically and efficiently. And for what we are doing, for the urban heat adaptation, to tell people the urban street walkability, to tell and also to tell the public which walk roads heat friendly. Yeah. So currently, the main research method we used to analysis or the investigate the urban heat challenges mainly include the field measurement and also the modeling. So for the field measurement, we develop a system like we call it the space, sky, and also the ground and the soil and the human. So I try to implement this for the field measurement. So for the space, we use the satellite, like the MODIS and the Landsat, to monitor the surface temperature of the city scale or the regional scale. So this is tell us the hotspots of the city. But we know the MODIS data, the data or the Landsat data, the accuracy or the spatial resolution is low, and also we can just get the temperature data around the 10 or 11 a.m. or in the midnight. This can not help us to monitor maybe the afternoon temperature data. So we also use the drone. One benefit or the one advantage is the high spatial resolution. We can use the precinct or the neighborhood or maybe a larger district is the spatial high resolution. This can recognize the different trees or the small trees or small land or the pocket park in the neighborhood and so on. And also we can recognize many other like a surface property with some temperature. Yeah, this is the one. And the second is the time or the temporal resolution. Yeah, we can use this to record the lesson temperature maybe at the time what we want. Maybe 2 p.m. or 3 p.m. We just know this 2 or 3 p.m. are the hottest time in a day, right? But compare the Landsat just the 10 to 11 a.m. So based on this, we can also tell people in what can the time we have the many risky areas, maybe at 2 p.m. or 3 p.m. or 4 p.m. And even we can tell people throughout the day, maybe from 1 p.m. or to 5 p.m. This is the risky hours. Yeah, this is the sky using the drone and the thermal camera. And this is to tell people in the high on the temporal resolution. And also, but these are just for the surface temperature. But we are also first on the outdoor thermal comfort. So we need to collect the data on the air temperature resolution, humidity, and all the mean radiant temperature, and also global temperature, and also for the wind speed and so on. Yeah, this is actually to break or to overcome what we cannot connect the surface temperature with thermal comfort. Yeah, so we use the like the mobile station, like the microclimate weather station, and we use maybe the fixed or the mobile station. The mobile station we can track the different road, the different stress on the different roads. It is dynamic. Yeah. So and this is for the air temperature or the some comfort. And also we are focused on the measurement of the soil temperature. We would like to see, and also on the extreme heat, or how about the soil temperature or the soil moisture. Yeah, their variation. Yeah, this may be. Yeah. So first, I have to say validation is the very important work is for the simulation, because if a simulation without enough validation, the accuracy and the result robustness cannot be guaranteed. So, but in many research or the published papers, no validation. So we have criticized this problem many times. So we are highly respect the importance of the validation. So we use the mobile measurement to all the field measurement to collect data like the soil temperature or the ground temperature and the air temperature, oven speed, and so on, and even the mean reading temperature. So once we use the environment simulation, we got the data, we validated it. We use the R-square or the RMSE to see how about the results of the simulation robustness or the accuracy. Maybe we can measure the temperature of the asphalt and also the on the ground temperature with the soil. And this is actually very important to force the simulation method, because we currently for the environment, yeah, this is another part on the modeling, yeah, right? So for the environmental simulation, we need a lot of raw data or the original data to force the platform. So based on this, we need to input the soil temperature or the ground surface temperature. And also we need to input the air temperature, the expected wind speed. Yeah, this is important. And also we need to validate the results, like the mean temperature. So the benefits for the international students include many parts. So the first one, I believe Chongqing University has a lot of support, especially for the economic support for the students. So we offered the different scholarship, maybe the CSC from the central government, and also from the Chongqing government, and even for our Chongqing University, we have the precedent especially precedent scholarship for the students. So yeah, and actually for this scholarship is much higher than our local students actually. So also based on this, they can cover their accommodation and offer the flight insurance and the daily functioning and so on. And yeah, one more benefit, we have very luxury accommodation room for the international student, same price and also the very much luxury than the local student as well. And also for the students, we offer a lot of chances to communicate with the Chongqing government, and we have a lot of to see and to let them to understand Chongqing and to understand and our strategy. We encourage them to learn more, and even after the graduation they can reside in Chongqing. And so I believe many students, they graduate and they supported by the Chongqing government, they do their business and to have their own company in Chongqing. And also they are setting up their maybe the design studio and their own company as well. And also for the student exchange, so they can get into the lab. Yeah, they can share a lot of facilities. Yeah. So the word I would like to suggest for the international or the overseas partners or the collaborators to learn is he. It's not my surname. Yeah, it's he means peace, and I want to suggest this word because first China would like to pursue the word is peace. Because in China, you may know, we have many the majority groups, and we have different parts of the culture or the religion and so on. So we would like to different people can understand. Yeah, and also I would like to suggest the word he is to suggest because our world is facing many challenges, the He is in opposite meaning of the challenge. To reduce all the eliminate the wars or the conflict among different countries, we need the peace. We need to make the peace of the human or the harmony of the human. Yeah, that's all. Thank you.
Professor Bao Ji He in his office, and he has some wisdoms to share. So let's start.
Yeah. So the first one is to see the future, and the second one is from 0 to 1, and the third one to think systematically, and the fourth one to serve the society.
Okay.
My name is Luo Yu. So I'm the latest of Chongqing. So I'm studying in Japan, Chongqing University, Faculty of Engineering. Research topic is about the selection of cooling infrastructures based on economic benefits.
好，我是重庆大学的一名研究生，我的名字叫陈翔，我来自中国的福建，武夷包村，我目前主要的研究方向是建筑的照明，主要包括室内的健康照明，以及一些城市的夜景照明的方向。
I'm Huang Boze. I'm studying in Chongqing University. My research topic is about urban thermal environment and human thermal comfort. That's all. Thank you.
是国际城市规划。You can understand better and. I just see.
Cheers.
Yeah. Cheers.
We did the converse and we need to get on 6. 6.
Thursday evening.
You say which is the best time for you?
Yeah.
So Thursday night, right? The meeting?
Thursday night. So Thursday 8 o'clock in the evening PM.
So it's now?
So this is the end of today's video. We're in Chongqing University. Thank you very much, Professor Bao Ji He, for hosting me. It was amazing. We had a lot of lectures. We talked a lot about scientific work, met a lot of your PhD students. I want to thank all your PhD students, and I hope I come back, and I hope international students will be interested to come to Chongqing University. Thank you.
You are most welcome.
Thank you. Bye-bye.